Hey everyone! I wanted to make a video to help you out with 2 points on the homework and lab this week. The first is using StatKey to work on the lab. There's a component that's missing and the picture is not super helpful, so I will demonstrate that for you. So the idea of the lab is that we're going to use an image of a sampling distribution, which is going to be the basis of our confidence interval. So when we're in StatKey here, we're going to choose the data set that is Manhattan apartments, and that's the rent prices. And then in that image, there are 2,000 samples drawn. So what are we doing? We're actually pretending like we're going to, I don't know, Craigslist, let's say, in Manhattan, and we're going to choose 20 random apartments and find out their monthly rent, and then compute an average. So I'm going to do that just once. So here's my average right down here at the bottom of the graph. And over here on the side, I have those 20 apartments that I sampled. So there are 4 dots right here, and you can kind of see the rent prices, 18, 19, 1800. And then there's some 2500, 23, 26, and there's one apartment that rents for nearly $5,500 a month. This is my sample of 20 apartments. So here's a list of those 20 apartments. And the average of those 20 apartments, here's the mean, 2805. And there's the median, there's the standard deviation of that one little sample of 20. Now, let's say that I have a friend who's trying to help me come up with an average price, and they go to Craigslist and take a random sample of 20 apartments in New York City. And here's their sample. I can show the data table. These were the rent prices from my friend's research. And then here is the average price from their research. So far, I'm liking my research better because the average price is lower. My friend's sample is showing that the average price is much higher, $32.20 for the average price per month. Rent per month. Okay, well, now I have a third friend that I'm trying to enlist in this because this is a lot of work myself. I'm going to generate a third sample. Oh, well, that's kind of nice. Here's the average, about $3,024 per month. Here's the sample data from my other friend. Well, let's say that I have a whole lot of friends and I can just keep generating sample after sample because each of my friends goes through and collects a sample of 20 apartment rents. And then we just start making this big old graph with all these sample means. So if we're trying to really estimate the average price of rents in Manhattan, let's say that I had, I don't know, a few thousand extra friends, and they're each taking a sample of 20. And I'm going to do this in one more time. So the samples up here show that I have, including myself, 2,045 people that are taking a sample of size 20 from wherever it is, Craigslist, whatever resource they have over in Manhattan to come up with apartment rents. We take lots and lots of samples and graph all of those means. And this is going to give us a pretty good estimate of what is going to happen in the actual population just by taking repeated samples. Now, this is kind of fictitious. I don't have that many friends to go through and take these samples. 2,000 friends. I don't have that many. So, this wouldn't actually happen. Now, there are people out there that do have lots of friends. They probably could generate this. And perhaps they could even generate like 10,000 samples. And you can kind of see what is happening when we take lots and lots of samples from a population. So the idea of the slide in the lab is that we want to come up with an interval. Where is a range of about 95% of all these data points? So here's 100% of the data points. If I were to come up with a range which gives me a certain percent in the middle, then I have a certain percent on each side. So notice 0.025 plus 0.95 plus 0.025 adds up to 1, so 100%. 2.5% to the left, 2.5% to the right, 95% in the middle. If we want to come up with an interval that is a 90% interval, I can click on the 0.95 and then in this box type in 0.90. And now I've created a 90% confidence interval. Here's the lower endpoint. Here's the upper endpoint. So a 90% confidence interval for the true mean apartment rent price in New York City, well, Manhattan. And to make a 95% interval, again, just click on the middle button and change it to 95. You could change it to 93 if that's the question, 99, whatever it is. You can also play around with this applet and see what happens if you like reset it and only take 5 samples. What would be the interval? You can also play around with this, not necessary, but you can edit the data and do some other fun things that I'm rambling now. So let's move on to the second piece. This is called a bootstrap confidence interval, but sometimes we want to make a confidence interval using a distribution that we definitely know about. And in this case, a confidence interval using inferential statistics. And here's our one sample proportion. We're going to use SALT to come up with a confidence interval for a population proportion. You'll want to put in the number of successes and the number of trials from the question at hand. Click on the button confidence interval. So actually, why don't I just redo this? Inferential statistics, one sample proportion, change my successes to, let's say, 500, and the number of trials to be, let's say, 1500. Choose the button confidence interval. Choose my confidence level. 95% is default, but you can click in the box and make it 90 or 99. Click generate results, and you're done. So a 99% confidence interval for the true population proportion of whatever the context is 0.30, let's say 0.302 to 0.365. And again, here are the statistics that we were using. There's your standard error. If you wanted to, you could also take the standard error, multiply by 1.96, and then add and subtract from your p-hat, and that's a 95% confidence interval. In this case, we did a 99%. If you have any questions, let me know. Bye.